So let us proceed with our discussion, my dear students. And we have been told that this progressive waves can happen either for the transverse or for the longitudinal waves. So a progressive wave is a transverse if the displacement of the particle in the medium are perpendicular to the direction of the wave propagation. Kwa tunaita kwamba hii transverse, tunaita kwamba hii wave hii progressive wave ni transverse wave pale ambapo zile particles zile displacement za zile particles in a median zinapokuwa zina propagate perpendicular to the direction of those waves, ndio tunaita transverse. When the wave direction are perpendicular with the particle perpendicular with the particle direction, hiyo ndo tunaita ni progressive waves ambayo inakuwa inatokea kwenye transverse waves. For instance, we are going to see the figure number 3. Ni figure number 3 for our topic number 8, trying to explain how this transverse waves, how the progressive waves is called the transverse waves. We have said that we try to say this is a progressive waves when the waves direction are perpendicular with this particle directions. So after there example of those transverse progressive waves, mfano wa zile transverse progressive waves, they include this wave in a ripple tank. Tuna ripple tank ambayo tulijaribu kuifanya experiment kwenye kipindi tuko form 4 pale. Kuna experiment kwenye kitabu cha Tai pale inahusiana na ripple tank. Kwa hiyo tumeambia mfano wa hizi transverse progressive waves ina include zile waves ambazo zinakuwa zina being formed kwenye ile ripple tank pamoja na light waves. So on the other hand, a progressive wave is longitudinal. Sometimes we say that this progressive wave is called the longitudinal wave, my dear student, if the displacement of the particles in a medium along the same direction. Kwa tunaita hii wave tunaita ni longitudinal progressive waves pale ambapo zile wave directions zinapokuwa zipo parallel na zile zinapokuwa zipo parallel na zile particle direction. Kwa when the direction of the wave parallel with the direction of the particles, this is called a longitudinal progressive waves, my dear student. And you have to remember that on this longitudinal progressive waves, we should have the two things. We should have this compression. We should observe the compression. We should observe the compression, the rarification. On the compression, we should observe that the particles are picked across to each other. While for this for rarification, we should observe that the particles are spaced. It means are in space. There are some distance are being formed because zinakuwa hazipo karibu sana, kuna kama distance ambayo kana being formed pale, ndio tunaita ni rarification ambayo ina happen kwenye hizi longitudinal waves. Lakini kule kwenye transverse progressive waves tunakuwa tuna observe kabisa kwamba tunakuwa tuna observe the formation of the crest pamoja na trough, because at the particle they could act perpendicular. The direction of the particle they could be perpendicular with the direction of the wave. This is what we have been told, my dear students. So the figure number 1C on the topic number 8, trying to explain the occurrence of this concept of this longitudinal waves, my lovely students. So again, example of those longitudinal progressive waves is sound waves. Mfano wa zile longitudinal progressive waves tunaongelea zile sound waves. The sound can be compressed or can be spaced each other. It means kwamba ile voice kwamba unapokuwa upo karibu unaweza ukasikia, unapokuwa upo bali unaweza ukaisikia ile sauti kulingana na an external force or external power that are introduced with someone who tried to call you. So as we have been told that the displacement of the particles in the both progressive transverse and also the longitudinal waves can be represented in a displacement distance graph as shown in the figure. Kwa anajaribu kuelezea kuwa hii displacement ya zile particles ambao zina happen kwa hii transverse progressive waves na pamoja kwenye hii longitudinal progressive waves, they are being represented by they are being represented in a displacement distance graph as shown in the figure number 3 for the topic number 8. Kwa tutajaribu kuangalia figure ambayo inajaribu kutupatia upatikanaji wa hizi transverse progressive waves pamoja na hizi longitudinal progressive waves. As we have been told that they should be represented in a graph, whereby the graph should be indicated at the vertical we should have the displacement, and at the horizontal we should have this displacement. That is why we call as the displacement distance graph. So as we observe, my dear student, this is our graph. This is our graph whereby on the vertical line we have this displacement, and on the horizontal we have this distance. As we observe the displacement distance graph as we have been told, my dear students. So as we seen here that we have two graph, we have two parts here. We have Alumni A, Alumni B, and also Alumni C. This is the figure that trying to elaborate about the progressive transverse and longitudinal waves. Kwa hizi ndo structure nzima ya zile progressive za transverse pamoja na zile za longitudinal. Sasa if we observe this, my dear student, the Alumni A trying to elaborate how these transverse waves happen, my lovely student. We see the direction of the wave move parallel. We see this wave move the direction of this waves is along the horizontal axis. But also we observe the particles, they trying to move upward and downward. It means that the direction of these waves and also this particle, they act perpendicular to each other, because the particles they tried to move up and downward, while these waves they move parallel to each other. As we observe here, my dear student, this could form the transverse waves. And also on Alumni B here, this is the demonstration of this Alumni A, my dear student. Here we are talking about the progressive. This is the transverse waves. As we see the waves trying to move, while the particles they move upward and downward, and finally they could produce at the perpendicular. It means that they move perpendicular to each other, my lovely students, as we have been told from the equilibrium position. They arrange into the equilibrium position. While on this, as we observe on the figure number C, on this figure number C, my dear student, we see how this longitudinal progressive waves happening. We observe the particles trying to move parallel. The particles they move parallel along to the direction of those waves. Waves zinakuwa zinaenda parallel pamoja na hizi particles zinakuwa zinaenda parallel. Finally, we should observe there's the formation of the compression, whereby the particles are picked together. And also we have the formation of this refraction. Kwa hiyo itakuwa inafika ngazi zinabanana zile particles, lakini inafika ngazi tena zinaachana nafasi. Kwa zinapo banana tunaita ni compression, lakini zinapoachana nafasi tunaita ni rarefaction, my dear students. So after there, let us try to observe the concept of this principle of superposition of waves. Tujaribu kuangalia kuhusu principle of superposition waves. So consider two waves A and B traveling in a medium in opposite direction. Imagine we have the two particles. Sasa particle A pamoja na particle B. We have two waves, the wave A and also the wave B. They're trying to move in the opposite directions. Of course, they move in opposite directions, we have been told. So suppose the crest of A. Now imagine the crest of A are trying to coincide with those at B. And the trough at A also they coincide with that at point B. This is how the figure number for A, for the topic number 8, trying to explain, my dear students. So the resultant displacement is larger. We should observe that the resultant displacement that gives the result of the wave A and also the wave B, they could be larger compared with those A and B. So now suppose the crest, imagine this crest of A coincide with the trough of B. Sasa inapotokea sasa hii crest A inapo coincide with this trough B, and the trough A anapofall kwenye ile crest ya B, kama tutakapoenda kuona kwenye figure number 4, my dear students. So then the resultant wave D is the sum of the amplitude. Kwa ile resultant waves ambayo tutaita ni D itakuwa ni result. It means it could be the resultant of those two waves, my dear. Na hiyo ndo tutaita ni superposition. So by saying that, let us stop here. We should come and proceed with the next part. My lovely student, have a nice moment.